Okay, in the previous two videos, we went through and found the corresponding eigenvalues to the matrix and one of the eigenvectors, that's the one that was corresponding to lambda 1 equals -1. So let's go through and find the other two eigenvectors. First, we'll take a look at lambda 2 equals -2. Remember again, this is the same thing as subtracting a -2 off the main diagonal. So this is actually -3, 0, 2, 6, 3, -12, 2, 2, -6. And again, this is minus a -2 times the 3 by 3 identity matrix. So again, in essence, we're going to just be adding 2 to the main diagonal of the matrix A. So we're going to be bumping it up by 2. So that matrix, when we go through, is going to be -3 plus 2 makes a -1. And then the other two numbers, of course, stay the same. So there's the 6. The 3 is now bumped up by 2, and that becomes a 5. And then the -12 stays the same. And then the 2 and the 2 stay the same. And the -6 bumped up by 2 now becomes a -4. Once again, we go to our graphing calculator and put this into row reduced echelon form. And again, all you have to do is go into second in matrix, go to edit, and just right over top of the previous matrix. And then you can quit, and then you could hit second and row reduced echelon form again. And this time around, you end up with a 1, 0, -2, 0, 1, 0, and a 0, 0, 0. And once again, you see that oh so important row of zeros. So now again, translating this back into A minus lambda I times V, we've got our vector V component-wise, and we got our 0 vector written out component-wise as well. We now translate this back, and this says that 1 times V1 plus 0 times V2 minus 2 times V3 equals 0, which says that V1 is equal to twice or 2 times V3. The second row says that 0 V1 plus 1 V2 plus 0 V3 equals 0. That forces the V2 to be equal to 0 because there's the only way that this equation can be true is that the V2 is 0. And of course, V3 is free, it's just itself. So writing this in vector form, we've got 2V3 in place of V1, 0 for V2, and V3 in place of itself. Factor out the common V3, and we get a 2, 0, 1 eigenvector. So 2, 0, 1 is the eigenvector corresponding to -2.